Welcome to this explainer. We hear the phrase 3 degrees of warming tossed around a lot in climate discussions. But today, we're cutting through the noise. We're going to unpack the profound, system-wide transformations our planet faces if global temperatures actually rise by 3 degrees Celsius. We're moving past the deceptive simplicity of that small number to look directly at the stark scientific reality of what it means for the Earth, our ecosystems, and human civilization. Here's our roadmap for today. We'll start with the deceptive 3 degrees, then dive into the physics and feedback loops, followed by ecosystems and extreme weather. After that, we'll look at the direct threat to humanity, and finally wrap up with tipping points and choices. Let's jump right into Section 1, the deceptive 3 degrees. To truly grasp the severity of this crisis, we absolutely have to shatter the illusion that a few degrees is just, the difference between wearing a sweater and a t-shirt. 3 degrees sounds totally harmless, right? Our daily weather fluctuates way more than that between breakfast and lunch. But in climate science, a plus 3 degree shift above pre-industrial levels represents a dangerous, largely irreversible climate regime. For context, we're already sitting at about 1.2 to 1.3 degrees warmer than that baseline today, and every single fraction of a degree pushes us closer to systemic instability. But here's the real catch. That 3 degrees is just a global average, and averages mask a brutal regional reality. Because oceans absorb heat differently than solid ground, land masses heat up exponentially faster, often 1.5 to 2 times the global average. So we're actually looking at plus 4 to 6 degrees on land. And the polar regions, the Arctic, practically bakes. It warms 3 to 4 times faster, potentially reaching a staggering plus 7 degrees Celsius or more. Moving right along to Section 2, physics and feedback loops. Now that we've reset our baseline, let's explore the fundamental physics of why this warming doesn't just politely stop, but actually accelerates itself. A perfect example of this is the ice albedo feedback loop. Normally, bright white ice acts like a giant mirror, reflecting sunlight right back into space. But as warmer temperatures melt that ice, it exposes the dark ocean underneath. Dark surfaces absorb heat instead of reflecting it, so the ocean gets warmer, which melts more ice, which exposes more dark ocean, and boom, warming accelerates globally. It's a self-reinforcing chain reaction. And it's not just melting ice. Warming is amplified by other massive feedback loops. You've got greenhouse gas forcing, and that's not just CO2, but incredibly potent gases like methane, which is literally 80 times stronger than carbon dioxide over a 20-year period. Then there's the water vapor feedback. Warmer air simply holds more moisture, and moisture itself acts as a greenhouse gas. Add in thawing permafrost, releasing trapped methane, and dying forests that stop absorbing carbon entirely, and you can see the problem. The planet basically continues heating itself up, even if our human emissions start to decrease. Let's look at what this means on the ground in Section 3, ecosystems and extreme weather. Okay, you might be wondering about a really interesting paradox here. How exactly can a warmer world result in both parched, dried-out Earth and massive torrential floods at the exact same time? It seems contradictory, right? Well, the answer lies entirely in the atmosphere's moisture capacity. That intense heat accelerates evaporation, which literally sucks the moisture out of the ground in places like the Mediterranean, Africa, and the Western Americas, causing severe droughts. But remember, warmer air holds more moisture, so all that saturated, heady air eventually has to release somewhere, dumping massive, unprecedented floods in other regions. Pair that with stronger tropical cyclones from warmer oceans and incredibly lengthened wildfire seasons, and you've got weather extremes hitting us on every single front. And beyond just the daily weather, entire biological biomes face total collapse. In a 3 degree world, coral bleaching becomes permanent, effectively destroying most reef systems. On land, there's a very real, scientifically grounded threat of the lush Amazon rainforest hitting a tipping point. It could suffer massive dieback and permanently transform into a dry, savanna-like ecosystem. This kind of biodiversity loss isn't just an ecological tragedy. It's a direct threat to the global agriculture and ecosystems that keep us alive. Which brings us to the most sobering part of our explainer. Section 4, the threat to humanity. As those natural buffers fail, the crisis tests the absolute limits of human survival. The crucial metric you need to know here is the wet bulb temperature, a combined measure of heat and humidity. At 35 degrees Celsius wet bulb, we hit the physiological limit for human survival. Even if you're resting in the shade, with all the drinking water in the world, your body simply cannot sweat fast enough to cool down. In a 3 degree world, densely populated regions in South Asia, the Middle East, and Africa will experience these conditions periodically. It makes outdoor work impossible and directly threatens millions of lives. This dual crisis strikes right at our most basic human needs: food and water. Heat stress and soil drying will cause global yields for essential crops like wheat, rice, and maize to absolutely plummet. At the very same time, our water supply faces a long-term decline. Glacier-fed rivers like the Indus, the Ganges, and the Yangtze, rivers that sustain literally billions of people, will begin to dry up as their vital snowpacks disappear. We are looking at volatile food prices, severe regional shortages, and widespread famine. Another physical reality locking in is sea level rise. Because water expands as it warms, and because the Greenland and West Antarctic ice sheets are melting, we are looking at sea levels rising anywhere from half a meter to a full meter by the year 2100. This locks in permanent coastal displacement and saltwater intrusion for major delta regions, island nations, and global megacities like Shanghai, Mumbai, Lagos, and New York. Socially and economically, we're looking at a deeply destabilized globe where the impacts scale non-linearly. Vector-borne diseases like dengue and malaria will expand into new, previously cooler territories. We're already seeing disaster costs skyrocket, creating entirely uninsurable regions as insurance companies pull out. Compounding disasters will chronically damage our infrastructure, and all of this combined, it's going to push hundreds of millions of people into unprecedented mass climate migration, massively increasing geopolitical instability. So, where does that leave us? Let's turn to our final section: tipping points and choices. Despite the grim scientific consensus, the sheer urgency of this moment stems from specific, irreversible tipping points. These are thresholds that, if crossed, mean the Earth's systems will fundamentally alter themselves no matter what we do with our emissions later. We're talking about the massive release of permafrost methane, the complete destabilization of major ice sheets, the death of the Amazon, and the severe weakening of ocean circulations like the AMOC. Once we cross these lines, we lose the steering wheel entirely. But, and this is absolutely crucial, we have not yet crossed that point of no return. The IPCC outlines clear, actionable mitigation pathways that can alter our current trajectory. We need rapid decarbonization of our energy systems, complete electrification of transport and industry, aggressive methane reduction, the scaling of carbon removal technologies, and the vital protection of our forests. This proves that a 3-degree future is not inevitable. It is entirely conditional on the deliberate decisions we make right now. I want to leave you with this final, incredibly powerful thought to consider. The defining question is no longer whether climate change is real, but how far we are willing to let it go before acting decisively. The tools to prevent a 3-degree world exist today. The real question is, will we deploy them in time to save the systems that sustain us, or will we let the clock run out? Thank you so much for exploring this vital topic with me today. Keep asking questions, keep learning, and let's face these realities together.